So this is a video explaining the group work that we were supposed to have done today, which was Friday. And I'm making the video so you guys could be better prepared for the next group work that we do on Monday. So number one, station one says, analyze the following XY tables, state whether they're growth or decay or neither. Now we're talking about exponential growth or exponential decay. So in order to do that, you need to look at your inputs and make sure that they're in consecutive integer order, and they are in order, -2, -1, 0, 1. And then we have the output right here of 16 and then 16, then 8, then 4, then 2. So what's happening to the outputs? Is it growing or is it decaying? It's decaying. And what's the factor? Esteban, what's the factor? How is it decaying? 16 times what gets you 8? 16 times what gets you 4? 16. 16 times what gets you 8? 8 times what gets you 4? 4 times what gets you 2? 1/2, right? So right here, it's a 1/2. This times 1/2 will get you the 8. 8 times 1/2 will get you the 4. 4 times 1/2 will get you the 2. So this is obviously decaying, and the base, the B value, is 1/2 because that's how it's decaying. It's the decay factor, 1/2. You guys follow me? Now, if you look at this next one, so this is definitely a decay function. If you look at the next one, you're probably thinking, oh, this is a growth function, 0, 4, 8, 12, it's growing. Okay, it is growing, but it's not growing exponentially. It's growing as a line. Okay, now what do I mean by that? Remember, an exponential growth or exponential decay, on your outputs, it's multiplying by something, right? 16 times half is 8. 8 times half is 4. 4 times half is 2. Right here, 0 times what gives you 4? It doesn't work. 4 times what gives you 8? Times 2. Okay, but then 8 times 2, does that give you 12? No, it doesn't work. So it's not growing by 2, so it's not an exponential growth factor. It's actually a line. So I guess right here, there's a common difference, not a common ratio. Right here, 0, I guess you could say plus 4, that'll give you 4. And then plus 4, that'll give you 8. And then plus 4, that'll give you 12. But that's not what exponential growth functions do. Exponential growth functions, you multiply them on your outputs. There's that growth factor that causes them to grow. So like, look at this next one over here. This one, they are in consecutive integer order, so you are able to look at the outputs. 1/2 times what gets you 1? 1 times what gets you 2? 2 times what gets you 4? So it's definitely growing. What's the growth factor? Times 2. So when you go 1/2 times 2, that'll get you 1. 1 times 2, that'll get you 2. 2 times 2, that'll get you 4. Does that make sense? So this is definitely an exponential growth function. The base is 2. Okay? So we could even take this a step further if we wanted to. So this middle one is not a growth or a decay. There's a common difference of 4 in each one of them, so that's a line. But when there's a common multiple, like right here, there's a common multiple, you're multiplying by 12. By 12, multiplying by half, multiplying by half, multiplying by half. Or right here, the common multiplying by 2, multiplying by 2, multiplying by 2. So this is a decay function, this is a growth function, this is a linear function. So this is not a growth or a decay, it's just neither. Okay? Now, we could take this a step further. Like, let's say I wanted to actually write the equation of this XY table. So we know that equations look like y equals a times b to the x plus k. Now, do I know? We know that this way it's growing, right? 1/2, 1, 2, 4, 8, 16, 32, and so on and so on. It's growing. What about backwards? 2, 1, 1/2, 1/4, right? 1/8, 1/16. So it'd be shrinking backwards. So what's the asymptote? What is the k value? Anybody? The k value. Now, if you don't see it, let's look at an XY plane. Let's graph 1, 4. Let's say 1, 1, 2, 3, 4 right here. Let's graph 0, 2. 0, 2 would be right there. Let's graph negative 1, negative 1. That would be right there. Let's graph negative 2.5, which would be right there. Then that's negative 1, that's negative 2. So we know that this is what it looks like. So what is your K value? So the K value is 0. We already know that the B value is 2. All we need to know is the A value, right? We know the B value is 2. We know the K value is 0. All we need to know is the A value, and we'll have our complete equation. Now, let me write down what we have so far. Y equals, we don't know A. We do know the base is 2, and it's to the x power. And we do know that K is 0, so I don't even need to put plus 0, but if I want to, I can. Now, all I need to find out is what A is. Now, in order to do that, I need nothing but numbers. So you guys see how we have an X up here and a Y right there? It would be nice if I had a number for X and a number for Y. Do I have numbers for X and Y? Absolutely. There's an XY table right here. So just pick one of these coordinates to plug in. Which one would you like to plug in? Which coordinate out of all these would you like to plug in? Pick one.
0.
0, 2? You want to use this one? Yeah. Okay, so let's plug in 0 for X and a 2 for Y. So notice that this equation starts with Y, so let's put 2 because 2 is Y, equals, I don't know A, but I do know that the base is 2, and to the X power, we just said X is 0. We're plugging in 0 right there. So let's plug in a 0 right there, and then plus 0. So here's our new equation that we could actually solve for A. So what is 2 to the 0? That's 1. You could just scratch it out. Plus 0, you don't even need that. You could scratch that out. So you really just have 2 equals A. And now we know what the A value is. Yay? So what is our complete equation? Well, remember, you need A, you need B, and you need K. You already know what A is, it's 2. You already know what B is, it's 2. So far we have Y equals 2 times 2 to the X, and we know that K was 0. So this would be your actual equation. They didn't even ask us to do that on this one. I'm just showing you that you can do that on this one. I think this is a good one to analyze. Just let's look at a bunch of graphs and state if it's growth or decay, all right? So the way to look at these graphs, you have to look at them like if you're reading a sentence. How do you read a sentence? From left to right. So we look at these graphs from left to right. Now, if it's from left to right, kind of like reading a sentence, from here, if you're going to the right, where's it going? It's going up. It's definitely growing, and it grows forever. So if from left to right it goes to infinity, then that's a growth. Whether it's a positive growth to positive infinity, or it could also be a negative growth to negative infinity. So this guy right here is definitely a growth function. Growth. Are you with me? Let's take a look at this one right here. Is that growing from left to right? So look, right here you're at the level what? At the level 4 on Y, actually 5. And then it decreases as you go from left to right to 3. And then it decreases to 2. And then it decreases to 1.5. Then it decreases to 1.25. And then it keeps decreasing, and it decays down to the value of 1. Does that make sense? So from left to right, is it going to infinity, or is it actually approaching a certain value, a certain asymptote value? A certain asymptote value. What's that asymptote value? 1, right? So this is definitely a decay. Decay. Let's look at this one over here. A lot of people make a mistake on this one. They say, oh, from left to right, it's going up. That means it's growing. No, that's not the case. A growth function is either going to go to positive infinity or to negative infinity. A decay function will always decay down to a certain value from left to right. So from left to right, is it going up forever?
No.
From left to right, is it going down forever? No, from left to right, it's approaching a certain value. What's that value that it's approaching?
Negative 1.
-1. It's approaching the value of -1, right? So this is called a decay function because it's decaying down to the certain value -1. You guys with me? And this is going to be on the test next Friday, growth or decay. Simple as that. Yay? Easy points, but a lot of people get confused with them. Let's move on to number 5 right here. What do you guys say this one is? From left to right. Look, it looks like it's not going anywhere. It looks like it's on a line from left to right. And then all of a sudden, it starts, what's it doing? Is it decaying or is it actually growing to a negative infinity? It's growing to a negative infinity. Okay? Maybe we need to understand this. Exponential decay. From left to right, it decays to a certain value. Okay, so let's take a look at, let's put this over here. Let's put these notes right here. From left to right, is it going to approach, is it going to decay to a certain value? Does it approach the number 3? Does it approach the number 4? Does it go to negative infinity? Does it go down forever? It goes negative infinity. So this is a negative growth. This is a growth in the negative direction. Does that make sense? So this is growth, even though it looks like, or some of us might mistaken it for a decay. How about this next one? Is that a growth or a decay? That's growth for sure. That's like the original, most basic one. From left to right, it grows. How about this guy? Is that a growth or a decay? It's a growth. Because it's going to negative infinity. So look, from left to right, does it approach a certain value? What value is it approaching from left to right? Negative infinity. That makes it a growth. But if it approaches a certain value like 3 or like look at this one. How about this? If I had something like this, that's approaching the asymptote 3. So that would be a decay right there, right? Make sense? Or even, let me erase this now. How about even something like this? Even though that looks like a growth, it's not a growth, that's a decay. Why is that? Because from left to right, it's approaching a certain value. What's that value? It's 5, the asymptote 5, right? So it's not that difficult. You got to look at it from left to right and see if it's approaching a certain value or if it's approaching an infinity. So right here, is it approaching a certain value or is it approaching negative infinity? Negative infinity, which means it's growth in a negative direction. So this is a growth function. How about number 8? From left to right, does it decay to a certain value?
No.
So what do you call this? Growth or decay? Growth. This is growth. Great. It looks like we know how to do this. Now, how about, what if I gave you just equations? Ladies and gentlemen, is this one a growth or a decay? The base tells you if it's growing or if it's decaying. The base 2 is going to make it grow. How about this guy? The base half is going to make it decay. Because it's less than 1. So like if you take any number and multiply it by 2, it's going to grow. It's going to double. If you take any number and multiply it by half, it's going to shrink. It's going to decay. So it's that simple. The base, if it's bigger than 1, it's going to grow. If the base is less than 1, it's going to shrink.
Wait, if it's bigger than 1, it's going to grow?
Yeah. So technically, let me say this, guys. How about this one? Number 11. Y equals, it doesn't matter what you have out here, 2/3. And let's say inside this, the base, let's say I had a 1.01 and then a +8, whatever. Is that a growth function or a decay function? That is definitely growth. But it's going to grow super slow. Super slow. Why? Because this base is 1.01. Right? So if you multiply 7 times 1.01, it's going to grow, but just barely. It's going to grow from 7, it's going to grow to 7.07. So it grows a little bit. But it still proves the point that if your base is greater than 1, it's growth. If your base is less than 1, it's a decay. Now, another thing that we needed to do was state the range of all of these, right? So right here, what is the asymptote? We already know the asymptote is down here at -3. So what is the range of this thing? The range is y equals, or y what? Come on, guys, challenge yourselves. What's the range here? Greater than what? Greater than -3. Excellent. That's the range. Y is greater than -3. How about over here? What's the range there? Y is greater than 1. Excellent. Y is greater than 1. That's a range. Okay? Because remember, here's the asymptote. That's at 1. And this whole thing is above 1. So Y is greater than the asymptote. It's all above the asymptote. Let's look at this guy and determine the range. So the range here is going to be Y is what? Less than -1. Perfect. The range is Y is less than -1. How about this guy over here? What's the range there? Well, here's your asymptote. Y is less than 4. Excellent. You guys are getting this good. All right. How about over here? What's the range right there, guys? Y is less than 4 again. Okay, good. How about over here? What's the range right there? Y is greater than 0. That's right. How about over here? What's the range right here? The range, Y is less than 0. That's right. And this last one right here, what's the range? Y is less than -1. Ismail, you got it. Good.